Okay, guys, for the final lesson of our Unit 12 linear inequalities, okay, we're looking at absolute value inequalities, okay? So these absolute value inequalities, there's two separate cases. And the really nice thing about the 4.0 content for this unit, you guys, is those two separate cases actually tie in really nicely to our previous lesson on compound inequalities, okay? So greater than and greater than or equal to, these ones are actually going to act like our or inequalities. So remember what it means for absolute value. Okay, absolute value really is the distance from 0. Okay, we want something that's greater than or equal to 5. But remember, if I'm working with absolute value, okay, if I put -5 in for x, okay, that's still greater than or equal to 5 because the absolute value of -5 is 5. Okay, so these are going to act, our first case, greater than and greater than or equal to, are going to act like our or our first type of compound inequality, okay? So I put a closed circle at -5 and the arrow is going away, and then I put a closed circle at 5, +5, and it's going to the right, okay? So our first case, greater than or equal to, those are going to act like our or our first type of compound inequalities, okay? For our second case, hopefully we can do kind of process of elimination here. Our less than and less than or equal to are going to act like our and inequalities, okay? So remember, this is kind of how we write out our and inequalities, okay? So we want all the values that are between -7 and 7 that would make this true, okay? Now, hopefully when we think of this, we can put values that these arrows are kind of covering for both situations into our original equation and see if it makes sense. So let's go back up to the top one and let's see here. If I pick the value -7 and I put it in for x, right? Because this arrow is clearly covering over -7. -7, what is the absolute value of -7? +7. So 7 is greater than or equal to 5? Yeah, that's true. Okay, so kind of maybe play with some of the values that are being covered in these graphs and see why that the less than and less than or equal to acts like the ands, and the greater than and greater than or equal to acts like the ors. Okay, so for instance, if I pick the value -3, I'll put -3 in here. The absolute value of -3 is 3. So 3 is less than or equal to 7. Yeah, that's true. Okay, so the biggest thing I can tell you guys with this 4.0 lesson is to remember greater than and greater than or equal to are going to act like ors, our first type of compound inequality, and less than or equal to are going to act like and inequalities. Okay, so let's take a peek at some of these now. All right, for the first one, I have x, the absolute value of x is less than 4. Okay, so if I remember, less than or equal to is going to act like and. Okay, so we want this to act like an and inequality, which means they're going to graph together. Okay, so I could say, well, -4 is less than x, which is less than 4. Remember, I'm using -4 and +4 because what's the absolute value of -4? It's 4. And the absolute value of 4 is 4. Okay, so that's why we're picking these values. Now we want everything between these two values. Notice we're going to have open circles at both those spots though, okay? Because it's just less than. Okay, I'm going to put an open circle at -4, open circle at +4. I want all those values in between. Okay, pretty quick, pretty painless, right? We just need to be able to identify this. And again, if you have a hard time remembering that the less than the less than is similar to the and compound inequalities, you can always use your notes, and this is in your notes, okay? So if we look at the next one, number 2, I have x, the absolute value of x is greater than 3. Remember, greater than is going to act like the or inequalities. So I would have, sorry guys, the graph came up first. I would have x is less than -3 or x is greater than 3. Okay, remember, or compound inequalities have a tendency to graph away from each other. So x is less than -3 or x is greater than 3. I'm going to have my open circles at -3 and 3. And of course, -3 is going to be going to the left and +3 is going to be going to the right. And again, if you're struggling with kind of wrapping your head around this, let's just pick a value and put it in here and see if it's true. Let's pick -5. The absolute value of -5 is 5. Is 5 greater than 3? Yep. So that's why we're going this way. Let's try 7 over here. The absolute value of 7 is 7. Well, 7 is greater than 3, right? So that makes sense, okay? Greater than acts like or. Okay, number 3. absolute value of x minus 1 is greater than 2. Okay, this is where it can get kind of interesting here. All right, remember, since it's greater than, it's going to act like an or. Okay, now I just have to set x minus 1 less than negative 2, and x minus 1 is greater than positive 2. Remember, I'm getting this negative 2 and this positive 2 because I'm dealing with absolute values. We know that since it's a greater than inequality, it's going to behave like an or, which means it's going to graph away from each other. Okay, so x minus 1 is less than negative 2. And again, we kind of did this with our compound inequalities, right, guys? We just solved both of these and graphed them. So I'm going to solve it by adding 1. I would get x is less than negative 1. Of course, I know that's an open circle at negative 1. And it's going to go to the left. I'm going to solve the right one. It's going to be adding 1 to both sides again. I'm going to get x is greater than 3. Open circle at 3, and it's going to be going to the right. So here's my first one, negative 1. It's going to be going left. And here's my second one, 3. It's be going to the right. Okay? So again, x minus 1, it's the absolute value, so it's greater than, so we know we're going to deal with an or type of inequality. Okay, so I can just set those up in 2 separate inequalities and solve them. Okay, this solving process is just one step. We should know how to do that. Okay, number 4, I have the absolute value of 2x plus 5 is less than or equal to 3. Okay, less than or equal to is going to behave like a and inequality. Remember how I set up my and inequalities. I'll have negative 3 is less than or equal to 2x plus 5, the stuff in the middle, is less than or equal to positive 3. Okay? Now I just need to work on isolating this variable, just like we did with compound inequalities. I do that by subtracting 5. Negative 3 minus 5 is negative 8. 3 minus 5 is negative 2. Okay? And my last step here, guys, is divide by 2. Negative 8 divided by 2 would be negative 4 is less than or equal to x, which is less than or equal to negative 1. Remember, less than or equal to, they graph like and inequalities, okay, which means they're going to go together. So we want all the values between negative 4 and negative 1. So I'm going to have my closed circles because it's less than or equal to at negative 4 and negative 1. And I just want the values in between it. So I'm just going to connect the dots. Okay. So the biggest thing I would say with this 4.0 lesson, guys, is remember what graphs like what. Okay. And if you ever forget, you can always go back to that first section of the notes and just remember greater than and greater than or equal to, they're going to graph like or. Less than or equal to, they're going to graph like and. Okay. This part right here is going to be very helpful for you guys. Okay. Let us know if you guys have any questions. We'll see you in the next video.